Alrighty, let's talk about balancing these redox reactions. Okay. Um, Sometimes you can do this um, by inspection, right? The Gen Chem 1 way, how we learned how to do this. So if we had a reaction that was magnesium plus nitrogen makes magnesium nitride, okay? This is not balanced the way I've written it, um, but we can balance this by inspection. Um, because there's not oxygens in here, right? This looks like a normal Gen Chem 1, even though um, it is a redox reaction because magnesium and nitrogen are both 0, and they went into magnesium nitride, and the magnesium is +2, and the nitrogen is -3. Um, but to balance this, we're just going to need 3 magnesiums, and that's really it. Okay. A lot of redox reactions are a little bit more complicated than that, and we want to pay attention because sometimes they're run in acidic conditions. We're going to talk about acidic conditions in here. Sometimes they're in basic conditions. This one is neutral because there's not acid or base in there. It's just the things reacting. Okay. You could balance this little one the same way we're going to learn to do. Um, but since you can do it by inspection, we're not going to worry about it. Okay. Um, okay. What we're going to do is the half reaction method. Okay. This will work for any redox reaction, whether you can do it by inspection or not. Um, these are the steps we're going to go through. It sounds complicated, but it's really not too bad. Um, we're going to write your skeleton equation and make a note if it's acidic or basic, because this is going to be key. We're going to focus on acidic in this one. The next video, I'll do a basic example for you. We have to assign oxidation numbers and determine what's oxidized and what's reduced. We're going to make half reactions, and then we're going to balance each half on its own, which follows these steps. I'm going to walk you through this. We're going to do it. Um, and then we're going to add the halves together and cancel out anything that needs to be canceled. Okay. Um, let's just dive into it and do it. Okay. So, skeleton equation. This is your unbalanced chemical equation. Okay. Sometimes I'm nice and I'll just give you what that skeleton equation is. Sometimes I'm mean and I give you a sentence and you have to come up with what the equation is. So we're going to practice this. This is going to help you, force you to know what the names of things are. Um, I've put on the blackboard the Gen Chem handout for knowing what polyatomic ion names are, so that can help you refresh if we need to do that. Okay, but so what are we looking at? We're in an acidic solution. We have iron 2 ions. Okay. I'm going to put base labels on here. Ions are in solution. Okay, react with permanganate ions, and permanganate is MnO4. Remember in that other video I said we're going to see that a lot, so there we go. Produce, there's our verb, our arrow, iron 3 ions, so that's iron 3 plus, okay, and manganese 2, so that's manganese 2 plus, okay. This is our skeleton, and we'll recognize that we almost could balance this by inspection, but not really, because we have oxygens over here, but there's no oxygens over here. So you can't balance it by inspection because somehow we have to put oxygens over there. All right, let's do this. I'm going to rewrite this so it looks nice. All right, we're going to use the half reaction method. So the first thing we want to do is figure out what's going on. We want to assign our oxidation numbers to this as we go. Okay, low-hanging fruit first. Manganese here is +2 because of the charge. This is 3 plus, so this is +3. And this is 2 plus, so this is +2. Okay. Now, we know oxygen isn't going to be something that's oxidized or reduced, but we have to remember that this is -2 because there's 4 of those. That means the manganese is +7. Feel free to go back and review that redox number video if you need to. All right. Now that we've got this figured out, we need to figure out what our halves are. Okay. I always do the oxidation half first, but you can do whatever you feel like. Just make sure things are labeled right. Our oxidation half, remember in the oxidation half, our oxidation number has to go up. So that is our iron going from +2 to +3. So iron 2 plus. And for the balancing steps, I'm leaving the phase labels out. You can usually do that. Okay. We're not going to add any electrons. We're just writing what's in the skeleton to start us off. All right. That means the other things are the reduction half. So the manganese and the manganese. So that means MnO4 minus permanganate on this side and Mn2 plus on that side. All right. So there's our skeleton halves. First thing, okay, we have atoms, hydrogen, oxygen. We have four things to balance. I can't count apparently as we do this. Okay. Balance all the atoms that aren't oxygen or hydrogen. In this case, they're already done. There's one iron on each side and one manganese on each side. Balance any oxygen by adding water. Okay, so we have four oxygens here. So that means we need four waters. Nope, it means we need two waters because I can't do math. Two waters on this side. No, it's still four waters. I'm an idiot. Oh, I'm sorry. Anyway, four waters to balance the oxygens. Okay. Now we have to balance hydrogens because we just added hydrogens. There's 4 times 2, that's 8. So this side needs 8 H plus. Okay. Then we need to balance the charge, and we balance charge by adding electrons, and we always add electrons to the more positive side. Let's write this out. Add electrons to the more positive side. Okay. For reference, the oxidation should be on the right, and the reduction should be on the left. But there we go. All right, so in the oxidation half, we have a 2 plus turning into a 3 plus, so that means this side needs to have one electron so that both sides are 2 plus. Remember, we're not trying to get both sides to be 0, we're just trying to get both sides to be the same. Okay, now to do a little bit of counting on the reduction. The right side is a total of 2 plus, and the left side here is 8 plus for this guy and -1. So this is 7 plus. Okay. So to make +7 to be +2, we're going to have to add 5 electrons on that side. Okay. Now, what we're going to do is we need to add our halves together, but to do that, we have to make sure the electrons cancel out. So that's another thing we're going to write over here. Electrons, all electrons must cancel. All right. So what that means for us is that, make this better. All of our electrons must cancel out. So since our manganese half has 5, means our iron has to have 5. So what we're going to do is we're going to multiply this dude by 5. Okay. And you can either rewrite it or you can change the coefficients or however you want to show your work. Just remember that there's 5 of everything in here. Okay. Now that we've multiplied and we know our electrons are going to cancel out, we're going to add them together. Okay. So we know 5 electrons are going to cancel out. Okay. Everything else we're just going to write. So 5, and this is should be our final. So I'm going to go ahead and add the phase labels back in because we want to have phase labels when we're done. So 5 iron plus permanganate that are both in solution plus 8 H pluses in solution. Oh, excuse me, are going to give us 5 iron 3 plus and a manganese 2 plus and 4 waters. Now, if you have to guess, Phase label on water has to be liquid. Okay. All right. This is our final answer, and you can always double check to make sure everything's balanced as we go. 5 irons, 1 manganese, 4 oxygens, 4 oxygens, 8 hydrogens, 8 hydrogens. Atoms are balanced. This side is, if we balance charge, this is plus 10, this is plus 8, and this is minus 1. So this whole side is 17 plus. And then this side is 5 times 3 is plus 15, and then plus 2 more is plus 17. And so it's balanced. Uh, we confirmed that it's balanced. You don't always have to do that, but if you're worried about it, you might want to make sure that you confirm that it's balanced. Okay. I'm going to put my notes on Blackboard so you can see it. So there's other examples in there too, that you can work through on your own, and we'll get through this. And I will show you when we get into other stuff, that there are other ways, not necessarily other ways, but there's a shorter way to do this once we get into talking about electrochemical cells and stuff. Okay. But you got to be able to balance reactions because that's going to be on the test. All right. If you need anything, let me know. I'm always here for you, email or in person or whatever have you. Okay. And I will catch up with you later.